show of hands, how many of you understand and can speak some amount of English? I see all hands going up. There was a point in time when I would not have quite raised my hand. I remember as a kid, was privileged enough, but went to this school called Sardar Patel Vidyalaya in New Delhi, which made us very consciously, it had Hindi medium in the early stages. And I remember it used to be hard for me to strike a conversation in English. And in fact, if I was going to speak, I would ask my elder sister, okay, kya bolu? And really ask her and kind of have that whole plan for a sentence before trying to engage in that conversation. So fast forward, again, feel much more privileged now. But my point was that all of us who are in this room who understand English, I would consider the privileged ones. We have information at our fingertips. And I want to draw a contrast with this person, Kamla, who is, let's say, born in a poor family. She has aspirations, right, to have a very, very successful life, but doesn't understand English very well. How do we give Kamla access to the same level of information, right, as you and I? That was a question, right, that I have been challenging our team with. So I come from Google DeepMind, where our mission is to build AI responsibly to benefit humanity. And if we think about this whole field of AI, the field is very old, almost as old as computing itself. And in fact, there were many, many branches in AI, but one that really took off was this branch called machine learning, where you make machines learn from data. And then again, within machine learning, there were many, many different approaches. And one that really took off about maybe 14 years ago was this approach called deep learning. Again, based on artificial neural networks, loosely inspired by how the human brain works, but really became, again, with that initial success that they showed on this problem of image classification, right, where you basically, given an image, you have an AI model say what this image is all about. This is a leopard. It led to dramatic improvements in accuracy. And after that breakthrough, suddenly you started to have all of these other problems like speech recognition, from speech recognizing what were the words that were uttered, or given text in one language, translated into text in another language. All of these problems that researchers had been working for decades. Deep learning became kind of the best way of solving these problems. While you could get very, very accurate solutions, for every new problem, you needed to train a new network from scratch. And this is not how humans learn. I build upon how I've solved similar problems before. So that was, again, approach enabled by this, again, another transformation called the transformer architecture. It led to these large language models, being built, which would be trained on, again, large volumes of openly available data. And as you train these models, for instance, to predict the next set of whatever, either a missing word or the next set of words, they started to do some amazing things. Not just solve a whole bunch of natural language processing problems, but even a very, very broad range of problems. And in fact, this model called PaLM that was built by this Google team about 3 years ago, they compared the performance of this one model on 58 different tasks with the best known model for solving each of those 58 tasks. And this slide shows the relative performance that these orange bars show that, yes, the specialized model did better. But you see, on a vast majority of tasks, this one model started doing better than the best previously known specialized model for solving those problems. This is what led Stanford researchers to coin the term foundation models, that if you want to solve a problem, you have these very, very powerful pre-trained models which are providing a very solid foundation for solving that problem. Fast forward to today's modern foundation models. They are also known as LLMs, large language models. But today they have gone far beyond just language, just the text modality. Today they are multimodal in nature. And in fact, this is one example of such a model, that it can process not just text, even handwritten text, but also images. So this is kind of the prompt which is given to one such model, where it's asked this question: here's a solution to a physics problem by a student. The skier slides down the slope. What's the skier speed at the bottom? And this model is able to take this input and automatically infer that, oh, this is that problem where you convert the potential energy of that skier at the top into kinetic energy, plug in those equations, and what's the velocity of the skier at the bottom, and go back to what the student has done and find the error in their solution. Now, think about the implications of this kind of capability for learning. Because now that dream of personalized tutoring, an assistant that is available to you to help you in your journey in a very personalized manner, suddenly seems a lot more feasible. The other thing that these models brought was this ability to handle very large amounts of information just as part of your input. So even if the model hasn't been trained on that data, let's say 2 hours of video, which are given as input to a model, what can the AI model do? So this is again an example of a 45-minute video that has been uploaded. The model hasn't been trained on that video. It doesn't know about the contents. But this is given as part of the input. And the model is asked a certain
this drawing
question.
Of a scene we were thinking of and asked, what is the time code when this happens? This is an example of a multimodal prompt where we combine text and image in our input. The model returned this time code, 1534. We pulled that up and found that it was the correct scene. Like all generative models, responses vary and won't always be perfect. But notice how we didn't have to explain what was happening in the drawing. Simple drawings like this are a good way to test if the model can find something based on just a few abstract details, like it did here. These are just a couple examples of what's possible with a context window of up to 1 million multimodal tokens in Gemini 1.5 Pro.
The other very interesting thing that you see is that these agents are going beyond just simple chatbots, not just able to interact with you through these text chats, even voice-based interactions, now increasingly real-world interactions in 3D world. So take a look at this example.
Try to guess this famous figure.
That's a fun drawing. Is it Albert Einstein?
Yeah, what did he do around this time?
In 1905, Albert Einstein published his groundbreaking theory of special relativity. Do you want another hint for your drawing?
Does this remind you of any of his work?
Yes, that drawing reminds me of his photoelectric effect paper, which also won him the Nobel Prize in 1921.
Okay. Do you know who this is?
Is this a new famous figure? This makes me think of gravity and Isaac Newton.
Did he share anything with that first guy I showed you?
Both Isaac Newton and Albert Einstein were physicists who revolutionized our understanding of the universe.
Yeah, so this is the Astra prototype that was developed by my colleagues. But now think about the implications of this kind of a very universal assistant, which is available to each and every person on the planet, with fair amount of information about the world and available to us at our fingertips. So this is, again, what makes me really excited about this whole field. But there is one wrinkle. I talked about Kamla. While that image that I created was again using an AI model. But there are many real-world Kamalas out there who don't really still benefit from technology the way you and I might. So I challenged our team, and that's a key part of the mission of my own team here in India. How do we develop these technologies in a truly inclusive manner? So one of the areas that we saw was we wanted to be able to provide access to information to everybody in their native language. And what we saw was that all of the models, including our own, there's a big gap between their capability on a language like English and most Indian languages. Again, on this chart shows that gap. Here, the higher number is good, and these are the numbers in English, and the inner structures are showing, again, the performance of these models on other Indian languages of various models. So we challenged our team to close that gap. And in fact, I challenged our team, can you close that gap for all 22 scheduled languages? And it was very inspiring to see, again, my colleague Partha Talukdar, who leads that team, come back and said, Manish, you're not being ambitious enough. So he showed me this data from the Language Survey of India. It showed that there are 60 Indian languages which have over 1 million speakers each. And there are 125 languages which have over 1 lakh speakers each. So Partha said, let's build a model that understands at least each and every one of those 125 plus languages that are spoken by at least 1 lakh people in our country. Something easier said than done. The next thing he told me was that 72 out of these 125 languages are zero corpus languages. That means there's zero known digital data on those. And we know data is the fuel, right, for these AI models. The other thing that we know is the same language is spoken in so many different ways. There is a saying in Hindi, "Kos kos pe badle pani, char kos par vani." Every few kilometers, the taste of water changes, and every 4 of those kosas, the nature of voice changes. So that inspired this project called Vani, which we launched in partnership with Indian Institute of Science. We have been collecting voice data from different corners of India. And the idea is by the end of this project, we want to collect data from each and every one of the 773 districts in India. We have made data from the first phase available, and it covers 59 Indian languages collected from 80 districts. And 15 of those 59 languages, this is the first ever known digital data on those languages. And again, our goal is to uncover many more of those zero corpus languages as we capture the full diversity of spoken languages across our country. Then, of course, there are areas like agriculture. There are over 40% of people in India who are dependent on agriculture for their livelihood. And that's an area that has not really so far been very well touched by AI. Very proud of the work by my team, which has built the first such model using satellite imagery, which for the entire country, it will give you kind of an understanding of the landscape, including field boundaries, start to identify the crop which is being grown, show sources of water like ponds and wells and so on. And the idea is to build the foundational layers of a digital agri stack that can unlock a lot of use cases. In fact, we took inspiration from this Aadhaar stack, which has revolutionized mobile payments, right, for instance. And it started with that foundational layer of Aadhaar ID, a unique ID for each individual. So through this work, what we have done is taken that first step of being able to give a unique ID identifier to each farm, so that now you can allow various insights to be obtained at an individual farm level. When that farmer looks for crop insurance, let's say cotton crop, the insurer can actually confirm, yes, is this farmer actually growing cotton crop for which I need to sell them, right, that cotton crop insurance. And likewise, various government subsidy programs and so on make them more data-driven. And also make these large language models or these multimodal models, these very, very powerful foundation models, right, which have seen, again, a resurgence since the days of ChatGPT, right, coming out through OpenAI. The final point that I want to make is about not just these kind of all of these very practical sounding applications, right, that we are all very familiar with, but an area which is really getting completely transformed with the use of AI, and that's science, the field of scientific discovery. And in fact, we got a glimpse at what is feasible through examples like AlphaFold, which won a Nobel Prize in chemistry last year. And just to understand what AlphaFold did, if you go back to your high school biology, we all learned that proteins are the basic building blocks of life. They're made of these sequence of amino acids, which are represented through these characters. So the computers think of them as these set of strings of characters. And we know all of these proteins, every protein folds into a distinct shape that gives it its distinctive properties. So given this chain of amino acids, what is that shape that this protein is going to take? That's been a long-standing scientific challenge. The predictions that AlphaFold was making were very, very close to the ground truth, to the actual structure of some of these test proteins, right, that the researchers had uncovered their structure only recently and put AlphaFold to good use. And AlphaFold was also able to convey its confidence in its predictions. So what the team then did after this problem was considered solved is they predicted the structure of all 200 million proteins known to humankind and made them freely available. And so think about, again, the implications of this work in AI. A problem that used to take about 5 years of research could now be solved in a few seconds. And this work, which was equivalent to 200 million times 5, about 1 billion PhD years, was all done in a single year, in less than a year, and all of that data was made available. So today, we really believe kind of the sky's the limit. So I'm very, very envious of all of the young students in this audience, because I entered this field. In fact, at that time, I opted for computer science. I'd never even seen a computer. I'd heard about computers, but computers weren't very commonly available. So I'd not even seen a computer when I went for this field called computer science. But today, all of you students who are entering your careers in this amazing era where computer science has really started to transform every industry, every aspect of how the world is run, you have this amazing ability. Think of any problem that you're passionate about, and you can apply. Chances are you can apply fields like AI, technologies like computing, to make a substantial difference to that problem. The same person, Kamla, that I used to think about, that how do we give her access to the same level of information as you and I? Now my aspirations are much bigger. How do we enable Kamla and all of the Kamlas like her to be able to do Nobel Prize winning work? I think that's going to be feasible, in a not too distant future from now. So it's going to be amazing. Thank you all.